Hi, consider the curve y is equal to ln of x squared over x. Determine whether the curve cuts the x and y axis. Find dy by dx and the second derivative. Find any coordinates of the stationary points and determine the natures of any such points. Find the exact coordinates of any inflection points. Hence sketch the curve and then state the domain and range and investigate the concavity of the curve. Right, so for the x-axis, very quite standard, y is equal to 0. I would recommend, if you've got a graphics calculator, is to sketch this curve first to get an idea on what it looks like and see that the mass actually backs up the curve. Okay, so for the x-axis, y is equal to 0. So that means that ln of x squared is equal to 0. And as x cannot be equal to 0, let's do log to the base a of b is equal to c. Log of x squared is equal to 0. That implies that a to the c is equal to b, and therefore e to the 0 is equal to x squared, and therefore x squared will be equal to 1. X would be equal to plus or minus 1. Okay, and you need to do it this way because this curve is going to be have a domain of all of x, or we've got to consider it for all of x. Obviously it won't be equal to x. The curve then crosses the x-axis at minus 1, 0 and 1, 0. For the y-axis, x is equal to 0. For y is equal to ln of x squared, x cannot be equal to 0. The function does not cross the y-axis as y is undefined when x is equal to 0. Therefore, the y-axis is a vertical asymptote. Using the quotient rule, so it is good to learn rules, but the ddx of u over v is v du by dx minus u dv by dx over v squared. Therefore, dy by dx will be equal to x times 2x over x squared. So if you differentiate ln of x squared, you differentiate this bit here, the x squared, and get 2x, and then you put it over itself. Obviously, this is going to sort of cancel out in a minute. Minus ln of x squared, and the derivative of x is equal to 1, divided by v squared, which is x squared. Now, this x squared will cancel with that x and that x, and therefore you'll be left with 2 ln of x squared over x squared. For the second derivative, again it's type u over v, so it's going to be v, which is x squared, times the derivative of minus x squared, which is going to be minus 2x over x squared this time, because there's a minus sign in front. Derivative of 2 is 0. Minus 2 minus ln of x squared, be careful to put it in brackets, times 2x over x squared all squared. Okay, so with a bit of cancelling, that x squared and that will cancel out. So you're going to have a common factor of 2x that can come out, and then we're going to have a minus 1, minus 2, minus, and times the minus will give me a plus ln of x squared all over x to the 4th. So if we write that line out again, and now if we simplify this last bit, we're going to have x goes into that one time and into that one there. So we're going to have 2 ln of x squared, minus 1 minus 2 gives us minus 3 over x cubed. For max and minimum points, the first derivative is equal to 0. So this is the first derivative. So x squared can't be equal to 0. Therefore, we're going to get that 2 minus x squared is equal to 0. And solving this, ln of x squared is equal to 2. And then use log to the a of b is equal to c, implies that b is equal to a to the c. And that gives you that x squared, because b is x squared, the base of the logarithm ln is e to the squared, which means that x will be the square root of x squared, e squared, sorry, which is minus e, or e, and we're trying to solve this from minus x to positive x. We've got to consider both these solutions. Using the second derivative test, we have when x is equal to minus e, the second derivative will be 2 times the ln of minus e squared minus 3. That will give me, so minus ln of minus e squared is the same as 2, so you're going to have 2 times 2 minus 3 over minus e cubed. So you're going to have 2 over a negative, so this will be a minus 1, which will give you minus 2 over minus e cubed, which will become positive, which is greater than 0, therefore what x to the e is a minimum point. So I just correct myself, that's x to the minus e is a minimum point. So when x is equal to e, the second derivative will be 2 times ln of e squared minus 3 over e cubed. Again, we're going to get 2 times 2 minus 3 over e cubed, which gives me minus 2 over e cubed, which is negative, and therefore x is equal to e is a maximum point. So when x is minus e, we have to find the y coordinate, so we need to do ln of minus e all squared over minus e. That will give us minus 2 over e. This will be become e squared, and then therefore we're going to get 2 over minus e, which is minus 2 over e. And then when x is equal to e, y will be ln of e squared over e, which will give me 2 over e. A minimum point then will be at minus e minus 2 over e, a maximum point at e 2 over e. Okay, so far, if you're still with me, well done. Okay, so for points of inflection, these are going to be non-stationary ones. The second derivative will be equal to 0, so that will imply that 2 ln of x squared minus 3 over x cubed is 0. Well, 2 can't be 0, x cubed can't be 0, so we'll just need to solve the bit ln of x squared minus 3 is equal to 0. And similarly, as before, we're going to have ln of x squared is equal to 3. And as we have to consider negative x and positive x here, we will need to solve it like this. Log to the base a of b is equal to c, implies that b is a to the c. So that implies that x squared will be equal e to the cubed, and therefore x will be minus 3 over 2 e to the 3 over 2, or x is equal to e to the 3 over 2. Checking for change of sign in the second derivative, when x is minus e to the minus 3 over 2, so when x is equal to minus e to the 3 over 2 and x is just less than, the second derivative is less than 0. And when x is just greater than, the second derivative is greater than 0. So we just need to take points less than that and just more than that in order to find the resulting inequality. Okay, so x minus, as there is a change in sign, then x to the minus e to the 3 over 2 is a point of inflection. And so when x is equal to e to the 3 over 2, when x is just less than 3 over 2, the second derivative it will be negative, and when it's just greater than, the second derivative will be positive, and therefore e to the minus e to the 3 over 2 is a point of inflection as well. And so we need to find the y coordinates now. So y will be ln of minus e to the 3 over 2 squared, so the 2's will cancel out, and that will give minus 3 over e to the 3 over 2. Be careful to square the minus sign first, otherwise you won't be able to find any result. And when e is e to the 3 over 2, we get ln of e to the 3 over 2 squared over e to the 3 over 2, which will give me 3 over e to the 3 over 2. So minus e to the 3 over 2 minus 3 over 3 over 2 and e to the 3 over 2, 3 to the 3 over 2 are points of inflection. Okay, so if we come to the graph, okay, so the graph looks like this. Again, your calculator would look like this. You could get this accelerated effect by if you were to extend the y-axis, marking on the minimum point there with the exact coordinates, the maximum point here, the maximum point here with the exact coordinates. You're going to have one point of inflection here and another point of inflection here. Now across here to here, the tangent is across the top. That means it's concave downward. At the point of inflection, the tangent goes underneath. That means concave upwards, and the second derivative is positive. Here, the tangent's on the top up to this point here, and that means that the second derivative is negative. It's concave downwards, and then here underneath, the tangent would go underneath. That means that the second derivative will be positive and it's concave upwards. So the domain, okay, will be every value of x except x is equal to 0. This is an asymptote. And the range will be all of y, because you can get every single value of y out, including 0. And then for the concavity, concave downwards will be from x is minus e to the 3 over 2. And then this bit here, which is 0, x between be 0 and e to the 3 over 2, and then concave upwards would be from minus 3 over 2e to 0, not including these points, yeah, and then greater than e to the 3 over 2. Concavity is best look, where you draw the tangent. Is it above here? It's below here. Above here and below here. Okay, so it's quite a long video. Thank you very much for staying with me if you got to the end. I hope you've learned something here. Please feel free to subscribe to my channel, and in the link of this video you'll find a link to my massive video site where you'll find thousands of videos to help you with mathematics. Okay, thank you very much for watching. So here we got this GeoGebra app. So here, if we click on this, we can see that's the first derivative. So you can see that here you get a stationary point because the derivative is equal to 0. And here we seem to be missing one of the points here, but here it's equal to 0. I seem to have lost the point there, but never mind. Okay, and then when we do the second derivative, we get this point here, you get this point here, and this point here. We get what's known as a change of concavity. Now, why does that happen? Well, if we click to see the tangent, and we scroll the tangent along, here we can see the tangent is above the curve. Okay, at the particular point here, it crosses from one side to the other, and then it goes underneath the curve. And then it goes back on top of the curve again, still on top, still on top, still on top, and then at this particular point it will cross from one side to the other, and then you can see that it's underneath the curve. And that tells us about the concavity, and we can get that from looking at the second derivative. So here the second derivative is less than 0, concave downwards. At the point it will be 0. Here we get concave upwards, and here we get concave downwards, and here we get concave upwards, so we can see those points. So this GeoGebra app, I'll put in the notes of the video. I'll try and work out why it seemed to have lost a point there. There should be a point there. Okay, so the sketch is that. Okay.